So what we're going to do now is we're going to take a look at a third order differential equation that has homogeneous constant coefficients. A homogeneous third order differential equation with constant coefficients. Excuse me. And we're going to look at it and we're going to find its particular solution now. All right, so what happens if I don't just want a general solution, I actually want the particular solution to this as well. We've got d cubed minus 5d squared plus 4y equals 0. Notice again, constant coefficients, right? And it's homogeneous, so we're setting it equal to 0. So this is a third order differential equation. And just for the sake of ease, you can go in and utilize Symbol Lab or Wolfram Alpha or some other kind of computer program in order to actually simplify this polynomial. But we've got P of r, right, is going to equal r cubed minus 5r squared plus 4, okay, which ends up equaling r minus 2 squared times r plus 1. Okay? Now, the multiplicity of the root on r is 2. So we're going to end up with r equals 2, but with a multiplicity m equal to 2, and we're going to have r equal negative 1. Since this is a third order differential equation, we're going to need three linearly independent solutions. And so the way that we're going to go about doing that is that our first solution, y1, will just be this e to the negative x. The second solution, y2, will be e to the 2x. And then in order to make the third one linearly independent and still have that power of 2, or 2x, we're going to have y3 will equal x e to the 2x. So notice what we're doing for each additional power beyond 1, right? So the first one is just going to be our standard e to the 2x. The second one is going to multiply by x in order to give us a linearly independent solution, right? And if we had, say, a third, it would be x squared e to the x. If it was the fourth power, it'd be x third e to the 2x. And then we would have 3 that would go along with that. In this case, we've only got the power of 2, so we've got these 2 that have this power of 2x. Okay? So our general solution is going to be y equals c1 e to the negative x plus c2 e to the 2x plus c3 x e to the 2x. Okay? Now, we're going to be looking for a particular solution, so what that means is that I'm going to need 3 initial conditions for each one of these variables. So what we're going to have is we're going to have y of 0 is going to equal negative 2, y prime of 0 will equal 3, and y double prime of 0 will equal 2. Okay? So what I need to do now in order to find this particular solution is I'm going to need to take some derivatives here. Okay? I have y of 0, right? I know that y of 0 is going to, give me one of them. So y of 0 will equal simply c1 plus c2 plus, well, just c1 plus c2. Okay? Y prime is going to equal negative c1 e to the negative x plus 2c2 e to the 2x plus 2c3 x e to the 2x plus c3 e to the 2x. Okay? And then this one, y prime of 0, is going to equal negative c1 plus 2c2 plus c3. Okay? And then y double prime is going to equal c1 e to the negative x plus 4c2 e to the 2x plus 4c3 e to the 2x plus 2c3 e to the 2x plus 2c3 e to the 2x. Okay, great. And so y double prime of 0 is then going to equal c1 plus 4c2 plus 2c3 plus 2c3. okay, or okay, it's going to equal C1 plus 4C2 plus 4C3. All right. Now what we're given here is we're basically given here a system of equations, right? Actually, before I do that, I want to set what these are equal to. This is going to equal -2. This one here will equal 3, and this one here will equal 2. Okay, and we got those from here, right? Those values from our initial conditions. All right, so now let's set up the system of equations so we can solve. So this is C1 plus C2 equals -2, negative C1 plus 2C2 plus C3 equals 3, C1 plus 4C2 plus 4C3 equals 2. All right, we'll set this up as an augmented matrix. 1, 1, 0, -2, -1, 2, 1, 3, 1, 4, 4, 2. Okay. After row reduction, what we ended up with was okay. And so consequently, if you remember our general form, right, was y equals c1 e to the negative x plus c2 e to the 2x plus c3 e x e to the 2x. So now our particular solution will end up being y equals 15 e to the negative x plus or minus plus -17 e to the 2x plus 10 x e to the 2x. And that is our particular solution. All right? So if we want to think about this from a standpoint of what do we need to do, right? Okay. First, we're going to solve for the general solution using the characteristic polynomial, using the auxiliary polynomial. Okay. Then what we'll need to do is we'll need to go in and we'll need to say, okay, well, use the initial conditions to set up a system to find our coefficients. And that's it. All right. A couple things to note here, too. Remember that because what we have is we have a power inside of our auxiliary polynomial, because we have a power that is different from 1, right? Since this is the second power, that we're actually going to need to create two linearly independent solutions to this differential equation. The first one being simply the root of r minus 2, and the second one being x times y2. Okay? So that's basically how we're going to generate these. All right, that concludes it.